For most of the 20th century, the story of Britain and Ireland felt settled. The people who lived on those islands were ancient inhabitants, descendants of hardy souls who walked north after the glaciers retreated, put down roots, and never really left. Invasions came: Romans, Saxons, Vikings, Normans. But the thinking was that these were thin layers of new culture, painted over an old genetic canvas. The real ancestry, the deep ancestry, stretched back 10,000 years, unbroken. It was a comforting story, and DNA has demolished nearly every part of it. Because over the last decade, geneticists extracting ancient DNA from bones buried across Britain and Ireland have uncovered something no archaeologist predicted. The population of these islands wasn't slowly shaped by occasional migrations. It was replaced, not once, not twice, at least 3 times. And the people living there today share almost nothing, genetically, with the people who built the monuments we still visit. The question is, how did an entire island's population vanish? And how did nobody notice for 5,000 years? To understand what DNA overturned, you have to understand how solid the old story seemed. In the mid-2000s, 2 popular books made the case that the British and Irish were essentially one ancient population. Brian Sykes argued in Blood of the Isles that the majority of British DNA came from Iberian settlers who arrived after the Ice Age. Stephen Oppenheimer made a similar case. The idea was seductive. The deep Celtic roots of the islands were biological fact, not just cultural mythology. The evidence seemed to support it. Mitochondrial DNA, passed only through mothers, showed lineages common across Western Europe. Y chromosome studies found the R1b haplogroup dominant in both Ireland and Britain, the same haplogroup common in the Basque region of Spain. The conclusion felt obvious. These were the original settlers, and they had endured. Genetic maps of the British Isles showed a smooth gradient, more similar in the west, slightly different in the east. It looked like continuity with minor ripples. Textbooks printed it, museums displayed it, and for nearly a decade, it held. But there was a problem hidden inside the method. Mitochondrial DNA and Y chromosomes each represent a single line of descent, one ancestor out of thousands. They can show a lineage survived. They cannot tell you how much of the broader population was replaced around it. It is like finding one original brick in a rebuilt wall and concluding the wall was never touched. The tools of the early 2000s could see threads of continuity. They were blind to the upheavals between them. The first crack came from a cave in Somerset. In 1903, workers draining Gough's Cave at Cheddar Gorge uncovered a skeleton that would eventually be called Cheddar Man, Britain's oldest near-complete human remains, roughly 10,000 years old. For over a century, he was depicted in reconstructions with pale skin and brown eyes. The assumption was straightforward. He was an ancient Briton, so he must have looked like a modern one. Then, in 2018, a team at the Natural History Museum drilled a 2-millimeter hole into his petrous bone, a dense piece of the inner ear that preserves DNA far better than teeth or long bones. What they extracted changed the picture entirely. Cheddar Man had blue eyes, dark curly hair, and skin pigmentation associated with sub-Saharan Africa. Dark to black. The first modern Britons did not look remotely like the people who live there now. The genes for lighter skin arrived later, carried by farmers migrating from the Near East thousands of years after Cheddar Man's death. That same petrous bone technique, quiet and revolutionary, was about to reshape everything we thought about who built the great monuments of the islands. Consider Newgrange. The massive passage tomb in Ireland's Boyne Valley is older than the Egyptian pyramids, older than Stonehenge. Its entrance is aligned so precisely that on the winter solstice, a single beam of sunlight penetrates a narrow passage and illuminates the innermost chamber. The monument weighs an estimated 200,000 tons. Whoever built it commanded extraordinary labor and astronomical knowledge. But who were they? For decades, they were assumed to be descendants of the first settlers, a communal society cooperating to honor their dead. Dr. Lara Cassidy, a geneticist at Trinity College Dublin, expected the DNA from Newgrange burials to confirm this picture. When her team extracted a genome from the unburnt bones of a man found in the tomb's most sacred recess, decorated with elaborate carved stones, she saw something she had never encountered before. His 2 copies of the genome, one from each parent, were almost identical, not similar, nearly matching. The statistical signature was unmistakable. His parents were first-degree relatives, either brother and sister or parent and child. This was not accidental. The only societies in recorded history that practiced sanctioned first-degree incest were royal dynasties, Egyptian pharaohs, Inca god kings, Hawaiian chiefs, rulers so powerful that the normal rules of kinship did not apply to them. And here was the same genetic signal, 5,000 years ago, in the heart of a monument aligned to the sun. But there was more. The team sequenced 44 genomes from burials across Ireland, spanning 2,000 years. They found that individuals buried in passage tombs, including sites at Carrowmore and Carrowkeel in County Sligo, over 150 kilometers from Newgrange, were genetically related to the Newgrange man. This was not a village elite. This was a dynasty whose reach extended across the island for at least 5 centuries. And then they vanished. Around 2500 BC, something happened in Britain and Ireland so dramatic that geneticist David Reich of Harvard called it very dramatic. Unbelievable, almost. A new population arrived. People associated with what archaeologists call the Bell Beaker culture, named for their distinctive bell-shaped drinking vessels. They carried copper daggers, archers' wrist guards, and a genetic profile unlike anything previously seen on the islands. Before we see what the evidence reveals about where these people came from, if this hidden chapter of history fascinates you, subscribe so you don't miss future stories. The evidence is only now uncovering. In 2018, Reich and an international team published the largest ancient DNA study ever conducted, analyzing genomes from over 400 prehistoric Europeans, including 226 individuals associated with the Beaker culture. The results for Britain were staggering. By the Middle Bronze Age, around 1500 BC, a minimum of 90% of the existing gene pool had been replaced. 90%. Plus or minus 2. The Neolithic farmers who built Newgrange and Stonehenge were virtually gone. Their Y chromosome lineages, once ubiquitous, were swamped by a haplogroup called R1BM269, carried by 84 out of 90 Beaker-associated males tested. New mitochondrial haplogroups appeared that had never existed in Neolithic Britain. Both men and women had crossed the sea. Here is what that evidence shows. First, the measured relationship. Beaker period individuals in Britain derived the overwhelming majority of their ancestry from populations that lived on the European continent before 2450 BC. The replacement was not gradual blending over millennia. It was near total within a few hundred years. Second, what it rules out. This was not cultural adoption, people learning to make bell-shaped pots. In continental Europe, the Beaker culture did spread as ideas. Iberian and Central European Beaker users were genetically distinct. But in Britain, the culture arrived with the people. The DNA is unambiguous. Third, what it implies. A society capable of building Stonehenge and Newgrange, a society with dynastic elites and solar alignments and passage tombs spanning centuries, was swept aside. The mechanism remains debated. Some researchers point to a plague pandemic that struck Europe around 2800 BC, possibly weakening Neolithic populations, while steppe-descended groups carried immunity. Others note that no clear evidence of mass violence has been found. Whatever happened, it happened fast. But the question that haunted researchers was, where exactly did the Beaker people come from? For years, the answer was vague, somewhere on the continent, carrying steppe ancestry. Then, just days ago, a study published in Nature on February 11, 2026, gave a precise answer, and it was not what anyone expected. Reich, together with Inigo Olalde and over 40 collaborators, sequenced genomes from 112 individuals who lived between 8,500 BC and 1,700 BC in the Rhine-Meuse Delta, the waterlogged lowlands of what is now the Netherlands, Belgium, and Western Germany. What they found was a population that should not have existed. While Neolithic farmers had replaced hunter-gatherers across virtually all of Europe by 4000 BC, this wetland community retained approximately 50% hunter-gatherer ancestry, 3,000 years after it had vanished everywhere else. The regularly flooded landscape of rivers, marshes, dunes, and bogs was inhospitable to farming, but rich with fish, waterfowl, and game. These foragers held on. Evelyn Altina, an archaeogeneticist at Leiden University, described the region as an island of persistence. While every surrounding population was absorbed by incoming farmers, the waterlogged lowlands acted as a natural fortress, not through walls, but through terrain. The land itself resisted agriculture, and the DNA shows that farmer ancestry arrived almost exclusively through women who married into the community, bringing pottery and grain cultivation without displacing the local population. For 1,500 years, this exchange continued. The foragers adopted tools. They kept their identity. Then, around 2,500 BC, steppe migrants arrived and mixed with these resilient wetlanders. The result was a new genetic combination found nowhere else in Europe: half forager, part farmer, part steppe herder. And these people, this unique blend from the Dutch swamps, are genetically identical to the Bell Beaker individuals who crossed the North Sea and replaced 90% of Britain's population. The ancestors of modern Britain did not descend from Mediterranean farmers or steppe warriors alone. They came from fishermen and foragers who survived in marshland for 3,000 years while the rest of Europe transformed around them. Not every researcher agrees on the details. Some archaeologists caution that the word replacement implies violence the record does not show. Julian Thomas of the University of Manchester has argued that drawing sweeping conclusions about social hierarchy from single burials, like the Newgrange man, pushes the evidence too far. Cardiff University's Alastair Whittle has suggested that the elite at Newgrange may have emerged temporarily in response to a climate crisis around 3,500 BCE, not as a permanent ruling class. Others point out that some Neolithic ancestry did persist. Roughly 10% survived the Beaker transition, and the mechanism of replacement itself remains one of archaeology's most heated debate. Was it a plague that decimated weakened farming communities while steppe-descended groups carried immunity? Was it a slow demographic squeeze, newcomers simply having more children over generations? Or was there violence we simply have not found? The bones, so far, do not scream, but the genes speak of erasure all the same. This is why the modern English carry more early farmer DNA than the Scots or Irish do, not because the farmers endured in England, but because a later wave from France, during the Middle to Late Bronze Age around 3,000 years ago, reintroduced that ancestry and changed southern British genetics by roughly half. The Scots and Irish, meanwhile, are more direct descendants of the original Beaker migrants. Layer upon layer, the genetics reveal not one story, but many, each overwriting the last. And the overwriting did not stop in prehistory. Ancient DNA from the Anglo-Saxon period tells yet another story of transformation. A 2022 study analyzing genomes from 278 early medieval individuals found that around 75% of the ancestry of people in eastern and southern England came from continental migrants, people genetically close to modern Dutch and Danish populations. But critically, the integration was not uniform. At a cemetery in Oakington, Cambridgeshire, migrants and natives were buried side by side with identical grave goods, No distinction in death, despite different biological origins. At Appledown in West Sussex, they were buried separately. Some communities integrated, others did not. And the modern English carry only about 40% of that Anglo-Saxon heritage, diluted further by centuries of subsequent movement. Viking DNA runs through all of Britain and Ireland, up to 16% in Scottish populations. The Irish DNA Atlas has revealed that genetic clusters across Ireland still map onto boundaries of ancient kingdoms: Connaught, Leinster, Munster, and Ulster, with a sharp genetic barrier slicing across the north that no historian predicted. Today, the skeleton of Cheddar Man lies in a glass case at the Natural History Museum in London, dark-skinned, blue-eyed, 10,000 years old. Around 10% of indigenous British ancestry traces back to his people. The rest was carried in by strangers who arrived in waves, each one reshaping the islands almost beyond recognition. If this hidden chapter of history intrigued you, subscribe to explore more mysteries. The evidence is only now revealing. The people who built Stonehenge did not descend from Cheddar Man. The people who replaced them came from a swamp. And nobody who lives in Britain or Ireland today meaningfully descends from any of the builders of the monuments their nations claim as heritage. If the islands have been repopulated this many times in just 10,000 years, what does that say about how we define who belongs to a place?